going to turn the floor over to John Marshall. Thanks, John.
Great, thanks everyone for showing up, and yeah, hopefully this is a good start for these methods chats. So this paper is kind of motivated by mostly just me seeing lots of talks given where people are using close selection, regression, discontinuity designs to identify what in principle I think could be basically any characteristic that you can measure, and so seek to see the effects of that characteristic on downstream outcomes amongst politicians which were elected. So it's kind of motivated me to think more about, well, if there's potentially infinite numbers of possible treatments that can come from a single source of close selection randomization or close to randomization, then this seems like a great source of a design. On the other hand, maybe it's sort of too good to be true. And I think, unfortunately, this sort of paper has a somewhat sort of negative implication. I think the answer is closer to it's too good to be true. But I'm sort of really looking forward to seeing what your reactions are to this. So like the paper's main results, I think, are largely done, but the sort of implications for applied research are very much sort of up in the air. And given some authors of some of the types of papers which I'm studying in the audience, like I'm particularly keen to hear sort of people's reactions to sort of what the implications are for good practice here. So in the context of close selection, regression, discontinuity designs, I think there's sort of two classes of design. The first one is the case where you use close selections to vary who wins and who loses. So it's sort of a comparison between politicians which narrowly won to politicians which narrowly lost. And this has been used to identify things like returns to office. So comparing politicians that narrowly won office, like how much income do they have at death or later in life. Similarly, I think this design applies to incumbency advantage papers under the proviso that we're in a context where the same parties run in every election. So you can compare a case where like the Democrat narrowly won against a Republican, how likely are they to win against a Republican again in the next election? It doesn't work so well for at the candidate level where candidate decisions to run are endogenous. So those aren't the cases I'm going to be talking about today. The ones I'm going to be talking about today are these sort of comparisons between narrow winners of different types. So the idea here is that you're going to compare two politicians who both say got 50.1% of the vote, but they differ in some way. So that could be ascriptive characteristics like their gender or their race. It could be prior actions of a politician. So this kind of case might be something closer to comparing two incumbents which narrowly won, which differ in how they performed in terms of corruption, differ in terms of how much experience they have in office, these types of characteristics. We can also think of this in terms of partisan affiliation. So this is, I guess, rather than a descriptive characteristic, a label which politicians can sort into. And finally, we see many designs looking at things like government alignment. So is this politician connected to the president, or is this politician connected to like a state governor or, in some way? Like that could be through partisan alignment, it could be through other types of connection. So these studies have really exploded. I'll show you some more sort of data on that in just a second, but there's been about 70 of these papers already published in the last sort of decade or so, and a huge growth in particularly like the last 5 years. So I think the appeal of these designs is fairly obvious, particularly to an EGAP crowd. So obviously it's the case that it's hard to estimate the effects of politician characteristics. Like we know that different politicians aren't randomly assigned to like have different genders or have different levels of competence. So finding a way in which we can seek to sort of speak to the question whether or not more competent politicians preside over better outcomes is obviously a very appealing prospect for political scientists and also to many economists as well.
So John, I think you suggested that we just kind of interrupt you, right? Rather than use the chat. Is that because the chat's difficult for you to see?
Yes, please do.
Okay. Miriam, do you want to, is that a question for now or for later?
Here's something I thought maybe someone else had heard it better and would be able to just tell me in the chat, so we didn't have to interrupt John.
Sorry.
John, I'm sorry to interrupt with this question. It has to do with my poor speakers here, or my hearing. Did you say there were 70 studies of the latter type that compare narrow winners in the last decade? 70?
Yes, that's right. I'll show you some statistics on that in a couple of slides.
Wow, I didn't know there were any. This seems like a really questionable design, so I'm dying to see you go after it.
I'm also interested in hearing you explain what people think they're doing, how comparing narrow winners helps them learn about the effect of gender. If I assume you're going to go there, is that right?
Yeah, I'm going to go through that particular example. I mean, I don't think that. To precursor the sort of conclusions. I mean, I think there are good reasons to think why this might help.
Okay.
I think it's just not going to do as much as some people claim. So,
cool.
I think the idea behind these designs, which sort of speaks to this question, is to say that, what close elections can do is they randomize who wins an election, and so there's this sort of appeal of comparing like a type X that wins to a type not X that wins when that type X is in a race with a not type X, and that type not X is in a race with a type X. So we're like always focusing on close elections between someone which has the characteristic and someone which doesn't, and so each of those races is randomly decided. So I think that's a sort of appeal to it. Like the part which is less obvious is whether the consequent claim, at least in many of these studies, is that this type of design is going to be able to isolate the effect of X, holding constant all other characteristics that could affect downstream outcomes, which I'm going to call this vector Z. So as I mentioned, there's 70 published papers. There's also a lot of unpublished papers as well, which I'm not going to talk about, partly due to my inability to be able to identify all of them, but also sort of out of fairness to people which haven't yet fully completed the paper. So to Miriam's point, I mean, 10 of these have been published in APSR, 3 in AJPS, 6 in JOP. It's not just a political science approach. Like basically half of these 70 papers have been published in economics, including in 4 of the top 5 econ journals as well. So I think it's far from obvious to many people, at least, that these designs may not be quite as compelling as people think. As I mentioned, 69% of these have been published since 2005. So I think it's sort of important to highlight. No. So in general, for regression discontinuity designs, I think there's a pretty good understanding of the variety of different estimation techniques that now exist, and I'm going to totally abstract from that issue, but there's a bunch of good review papers, particularly by Rocio Tituniuk out there, which can speak to this. I think it's also now the case that people pretty well understand sort of the need for a continuity assumption and the type of tests which you should be using to covariate continuity or balance tests, sorting or density tests. Like these are, as I'll show you in just a second, like pretty uniformly used in the literature. I think the other things which are pretty well understood in the literature are the effects of sort of in these regression discontinuity designs, not just in close races, but more the point of the discontinuity. I think most researchers sort of now add that caveat to their papers, which has obviously implications for external rather than internal validity. The other element, which is specific to what I'm going to be calling PCRD designs, so politician characteristic regression discontinuity designs, is an appreciation of sort of compound and bundled treatments, in the sense that if you want to identify the effect of like electing a black politician, the chances are that that black politician is also a Democrat as well, and so we're sort of got some kind of inevitable bundle. This part I think is less well appreciated, but as you can see on this slide, it's sort of fairly well appreciated, particularly in the kind of the gender and like very obvious individual level characteristics of politicians. So what this sort of table should hopefully be showing you in the first panel is that there are indeed 70 articles, the covariate continuity tests and the sorting or density tests. Like most of these papers include these as standard, and slightly more than a third of papers also refer to this sort of bundle characteristics issue, that treatment is not necessarily just a single attribute, but a whole bundle of correlated attributes as well. What's talked about a lot less is what I'm calling compensating differentials. So you can see that there's sort of 6 papers here, which I think, to be honest, I'm being pretty generous in including them as referencing what I'm going to talk about. I would only say that there's really a couple of papers which get into what I'm going to talk about a bit more in detail. As you can see, like, you know, there's quite a variety of different ways in which these designs are used. So people have been using them to sort of compare politicians that have a criminal history or not, people which have higher or lower levels of education, men versus women, sort of extremist versus non-extremist politicians, incumbents versus non-incumbents, politicians from different parties, so Republican, Democrat, like left-wing, right-wing, as well as sort of prior experiences, like whether people were like business people before they went into politics, whether they're from the working class, whether or not they have prior experience in office, as well as like race, ethnicity, religion, and in the context of China, class as well. So there's a lot of different areas which people have applied this type of design for, and as I mentioned, like these have been published pretty prominently. So there's probably something like 25 papers in like really top journals across economics and political science at this point. So this, at least to me, it said that this is perhaps something which deserves to write a paper about. That's, I think Miriam and Jake have been implying in some ways, perhaps like this paper is going to be kind of obvious. And so I'm curious to know people's reactions to that, but it kind of feels like maybe this paper needs to be written. So just to sort of give you the bottom line up front, like this is a phrase my wife uses all the time. She works in public policy space and always talks about bluffing. So she was pleased to see this title slide. So basically what I'm going to try to convince you of today is that these PCRD designs are going to induce a form of post-treatment bias, that this is going to arise essentially by design, like it's going to come from construction by focusing on close elections when the fact you're in a close election is potentially a function of the characteristic of interest. This is going to emerge even in a world where we sort of dismiss the possibility of there being these kind of compound treatments. So I'm going to be able to show that even if your characteristic of interest X is uncorrelated, at least unconditionally, with all other characteristics, then you still see this bias emerge because of the need for what I'm going to call compensating differentials, variables that need to be present in order to be in a close race despite possessing or not possessing this characteristic X. So I'm going to focus on single member plurality elections, partly because that's where many of the studies are, but also because it's the easiest case to see the types of bias that can emerge. But the same kind of logic is going to extend to multi-member elections. Sort of looked at like the politician on the cutoff of getting elected or not, and also to PR designs that leverage similar approaches. So this isn't specific to this electoral context, but it's an easy one to analyze. So I think sort of like the bottom line really is that these types of designs, without being explicit about it, essentially require invoking several much stronger than normal regression discontinuity assumptions in order to identify the effect of X. In particular, like the two ones which I think are sort of most relevant, which might potentially apply, are that X doesn't affect the vote share. So gender doesn't affect the percentage of the vote that a politician in a close election gets. Or alternatively, it might be the case that gender affects the vote share, but there's no compensating differential that is going to affect the outcome of interest. So it's going to be the case that like there's something which is keeping these people which are have a characteristic or don't in a close race, but that thing doesn't ultimately affect the outcome. So I'll be a lot more precise about what I mean by compensating differentials shortly, and I'll sort of go through an example in just a second to sort of hopefully increase sort of the clarity of the issue. So what I'm going to try and do is I'm going to talk about sort of in a very kind of like sort of non-formal way examples of possible problems. I'm then going to generalize this by putting some formal structure on the problem, firstly giving a formal example and then showing like the most general results I have. And then I'm going to talk about sort of some of the implications for applied research. So there's some pretty interesting approaches out there, like Dan, who I think I see in the audience, I think has like the most compelling way of thinking about the issue as being like, maybe we're interested in like this grand bundle of everything, which will include both correlated characteristics and what I'm calling compensating differentials. And I'll come back to sort of what I think are some of the possible trade-offs with that approach. So anyway, as I said, like, please feel free to jump in whenever you have questions. Like, I see there's some comments in the chat, but I can't actually see them. So do feel free to jump in whenever.
Thanks. I think we're just using the chat for kind of side conversation that might bubble up for if somebody wants to bring it up, but we won't necessarily, I think, need to interrupt you for these sorts of things.
Okay, fantastic. Okay, so let me start with two examples. So I'm going to use what I think are the two most prominent examples in the literature, gender and partisan affiliation. So I think there's about 10 papers looking at the effect of electing a man rather than a woman. So the estimand, I take it in most of these papers, is what's the effect of electing a woman rather than a man? The first thing with any of these types of designs that you have to decide is, what is this sort of treatment of interest? Like, what is this X? Like, what's included in the X and what's excluded from the X? And so gender, I think, is a particularly tricky case because there's obviously a lot of sort of debate about like, what does gender even mean? Like, is it the case like once we can partial out all of the other things that we think are like part of a gender effect, meaning left at all, or is it the case that there's like something about gender as distinct from everything else that might come with it? So this is the decision ultimately for the researcher. Like, I'm not going to make any suggestions about whether or not like we want to identify the effect of gender partialing out partisan affiliation, policy positions, competence, experience, etc. That's something for the researchers to decide, but my results are going to apply essentially to any case where you decide there's like some characteristics that we don't want to be part of this gender treatment, which are going to serve as these sets of things which are not part of the treatment, potentially be confounding. So in these designs, you're going to pick a sample of close elections where a woman narrowly beats a man or a man narrowly beats a woman. So this is sort of the typical setup. Like, you don't want to compare a woman to a woman. You don't want to take races where a woman narrowly beats a woman because there's no sense of like there's random whether a woman won or not. So this is always going to be the type of comparison which is leveraged. And this is sort of like what many studies would find. So I'm not offering a specific outcome here, but this is like just a plot which is showing like a large treatment effect for cases where just to the right of the dotted line narrowly won versus districts to the left of the dotted line where a man narrowly beat a woman in the election. And so the question is, yes.
Do you mind just giving us one example outcome just to fix ideas?
Yes, so one type of outcome might be like, is a woman elected in future? So this is a fairly common one. So this sort of idea that like, does having a woman like change how the electorate thinks about women in future and becomes more sort of likely to elect them? Like, do we think that women pursue different types of policies? Like, there's a sense in that literature that women might be like more favorable towards like educational investments versus like other types of things.
Got it. Thank you.
And so the key question here is, are women in close races similar to men in close races? And so a lot has been written about this, not in the context of regression discontinuity designs, but many people have argued, and it seems quite plausible, at least to me, that women which are in close races had to overcome biases against them to get that. So if we think that sort of barriers to entry to political office for women are higher than they are for men, then a woman who's in a close race might be better in some ways than a man in a close race because they had to overcome such biases. So we might sort of, for example, say that a woman who gets 50% of the vote is just more competent than a man who gets 50% of the vote And so this is sort of like, this is basically what I mean by a compensating differential. So slightly more formally, I'm going to call a compensating differential a variable or a set of variables, which I'm going to call Z throughout the talk, which could affect the outcome Y. So whether that be sort of future election outcomes, like policy decisions in office, performance outcomes in office. So these sort of compensating differentials are going to both potentially affect the outcome of interest, but also ensure that this candidate with the characteristic X is still in a close election with a candidate which doesn't have the characteristic X. So this is sort of basically something which provides for at least an expectation that candidates with and without X are still in close races with each other. And so just sort of taking this example of competence, we might think that if women who are in close races are more likely to be competent than men, then the fact that we saw this large treatment effect before, like what I'm calling tau hat here, so the estimated sort of PCRD effect, is actually quite large. Like this is actually going to be a compound of two things. Like it might be that women want more of the outcome, and when elected, they produce more of that outcome. But it's also the case that women are more competent because of this need to overcome sort of biases in the electorate. And so part of the large effect is due to the competence effect, and part of the large effect is due to the woman effect. And so this is sort of what I'm trying to capture with this grayer line here, which what you might think of as being the counterfactual, the comparison with men who are equally competent to the women which win. So these are sort of like on the left-hand side in gray, like this is the men which narrowly won close elections against a woman, but where the man and the woman were equally competent. And so you see a much smaller effect of gender in those cases where you've sort of effectively partialed out the impact of competence. So does anyone have any questions about this sort of example? This is kind of like the core logic for everything that follows.
Do you need a light gray line for the winners as well? Or are you assuming that the men and women who win would be equally competent?
So yeah, so the black line would be the case where they're not necessarily equally competent, and the gray one here would be for the case where they are equally competent. So was that your question?
I was just wondering, trying to get my head around why you'd only see the true counterfactual of equal competence, because on the right-hand side, it would imply that the men and women who win would be equally competent, right?
Yes, so you'd actually never see this true counterfactual, I think.
Right.
So this gray one would be unobservable. I'm just sort of putting it in here in like a world in which like somehow you could observe this, but I think sort of the essence of the problem here is going to be that by construction, you're never going to see like men which are equally competent as women in close races with women, precisely because of this bias in the electorate. So this is like what you would like to be able to get at, but won't be able to do empirically in practice.
So John, just to check my intuition, that I wrote this in the chat, but it seems like the attraction of this design that you're criticizing is that if you compared a man and a woman candidate where the woman won by 90%, everyone would assume that those two candidates differ in many, many ways. Maybe the female candidate has a lot more money, is much more competent, has more support for whatever reason. So any comparison of it's like the man is not a good counterfactual for her behavior once she's in office. Now, if they got essentially the same margin, that argument is not so glaring to us as it would be with the 90-10. But what you're showing here is there's still no reason, like close margin need not imply same fundraising, competence, etc. Is that kind of where we're going here?
Yeah, that's exactly right. And
Okay.
like this is I think the sort of, I'll come back to this at the end, but this is like the basic trade-off when thinking about whether these designs are better than like doing something which is sort of like controlling for a bunch of characteristics like campaign expenditures, etc. And yeah, I mean, the core of that trade-off is DRD designs are going to induce a bias by construction. but by conditioning on candidates which have the same vote share, you might be reducing a lot of other biases in some other way. And yeah, I'm thinking about trying to find ways of providing results for like when that bias is lower. Even though it's not unbiased, it's still less bad, but that's sort of like next steps. Okay, so let me just give another example from the most common application here. So there's many studies going back to sort of Lee, Butler, and Moretti's famous first study in this kind of line of designs is the effect of electing a Democrat rather than a Republican. So focusing here on sort of close races to typically the US House or lower state level elections, where a Democrat just beats a Republican or a Republican just beats a Democrat. So the type of possibility for compensating differentials is slightly different here because we're thinking about a label that applies to many candidates. Like it's not so obviously individual specific as like gender or experience or whatever. But the possibility for a need for compensating differentials is fairly obvious when you think about, say, like an election like 2018. So there's a big swing towards the Democrats. And so if you're a Republican in a close race in 2018 in the House, like you must be good in some other way in order to be able to still be competitive with Democrats, at least in the average district across the country. So if you think there's something like, a 7 or 8 percentage point advantage for Democrats, then the Republicans in close races on average would need to be significantly more competent or more aligned with voter interest or more left wing than a typical Republican in order to still be in a close race. And so this is then going to sort of have the same type of implication that you're going to potentially underestimate the effect of Democrats or electing Democrats if it's the case that like more competent politicians produce more of an outcome and Democrats produce more of an outcome, and so the Republicans which get elected are going to be more competent on average to compensate for like not being favored by the electorate at large, and so we're going to see a smaller treatment effect than you would purely for the effect of being a Democrat. So I'm partly using this example to sort of highlight a way in which the bias can go in either direction. So in the gender case, this was a case where we overestimate the effect of gender. In this example, where both Democrats and competent types produce more of an outcome, say like, they produce like more infrastructure spending, this would be a case where we might with these designs underestimate the effect of being a Democrat. And I think this is kind of important, and I'll come back more to this later as to why, because I think many designs are going to fit into this sort of box where perhaps we're looking at the lower bound of a treatment effect, which is obviously potentially quite useful from a directional kind of hypothesis sense. Okay, so let me jump into sort of formalizing this a little bit more and sort of hopefully like really showing you exactly where the problem is here. So I'm going to try to start by saying like, how do these designs differ from standard RD designs? And so I'm going to show both using exactly the same mathematical notation, and you're going to see that where the additional assumptions and where the differences in the sort of the estimand kick in. So throughout, I'm going to think about candidate I in district D, who's going to receive a vote share VID. We'll then define a forcing variable, which is going to be the difference in the votes between candidate I and the most popular candidate J, who's the candidate which wins, or the candidate which comes in second place. The treatment then is simply a binary variable for candidate I as treated. Vote share is greater, or their differential in vote share is greater than 0, so they won the election against the largest possible case where there's some candidate which had more votes than them. The observed outcome then is simply going to be like the weighted average of the case where you're treated and in the event that they're treated. Miriam, you had a question.
Yeah, John, I do have a question. It's slightly different than the direction you're going in, but to return to the literature. In the literature that use this design, how well do they justify the close election requirement. That is, how narrow are the bands that they're working in? How close are the elections that they study? Do you buy the as if random part even kind of in principle? Are they really close elections?
Yeah, so I think that's plausible. I mean, like studies vary depending upon the sample sizes. I mean, it seems like typically like you're looking at 2 or 3 percentage points either side of 50% or something like that. And you know, there's other studies like the EGAP et al. Piece, which show across a wide range of countries that this seems to be a fairly compelling design in terms of there's not strategic sorting around the discontinuity. For the purpose of what I'm doing, like I'm going to assume none of that's a problem. But yeah, I mean, I think this is an important thing to raise it in many contexts, particularly the studies which use much larger bandwidths and might be sensitive to.
Okay, but
like
these studies are not. They're not. You can't discount the studies on the grounds that the elections weren't really close. These were the evidence in the 70 published studies that the elections were adequately close to for that part of the design to be convincing.
Yeah, I mean, I'm not going to claim that they're all perfect in that regard, but my point is, you know, even if they were, like this would still, like what I'm pointing to is still going to be a challenge here. So yeah, so we have this observed outcome, which is either like the treated or the untreated version. Like this is just standard RD recap. The estimand is like conditional upon sort of being in a tied race. Sort of where Miriam's point comes in is typically something of this form, like we want to sort of approximate a limiting case, and I'm going to assume that the researchers have done a good job in this. So, you know, as Miriam's saying, that this is a function of like the sample size. Like there's a lot being written about like how to estimate these sort of like sort of edge cases for these expectations well. I'm going to assume for the purposes of this that that's been done perfectly. So the continuity assumption is also well known here. This is saying that basically no other variable is going to change through the discontinuity except for this treatment variable TID. So this is what motivates all the covariate continuity tests at which look people which narrowly win versus people which narrowly lose, similar in lots of other characteristics. So under this continuity assumption and abstracting from any issues about estimation, then the RD estimator is going to be an unbiased estimator of the effects. And so this is news to anyone here, I suspect, but it's sort of like the basis for the comparison. So the question then, I think, is how do the sort of politician characteristic RD designs differ from this? So the key thing to note here to start is that the unit of analysis is no longer the candidate, but the district instead. Like we're always comparing districts where candidates of type X1 to districts where candidates of type not X1. So we're going to redefine the treatment, the forcing variable, and the outcome at the district level. So this is sort of coming from the D notation, but I'm going to relate this back to the standard RD design by using the individual level notation to sort of link to the district level notation. So in terms of the forcing variable, we can call delta D the difference between the vote share of a candidate of type X equals 1 minus the vote share of the candidate of type X equals 0. So you know, this is always going to mean that delta D is like the votes in favor of the candidate of type X, the candidate characteristic of interest. The treatment to be if delta is greater than 0, then candidate of type X is equal to 1. In the case where the candidate of type X doesn't win, is equal to 0. And again, like the potential outcomes are going to be sort of captured at the individual level. So Y1D here is the potential outcome for individuals which have characteristic X and which win the election. Y0D is going to be characteristics, the outcomes of characteristics of not X when they win the election as well. Like it's worth noting here that we're never going to observe YID 0 because this is sort of not really relevant from this because these politicians never actually enter office, and so we don't count because we're only ever comparing winners. So in many ways, I think this is sort of like the key step to note here is that like the later of interest is now going to be slightly different. So in the PCRD design, we're going to be comparing the district level outcome where the politician of type X wins to not X, conditional upon the close race. We can then rewrite this in terms of the individual level characteristics. So the second line here is rewriting the district level outcomes all at the individual level. So this is the outcome for an individual of type X equals 1 who beats an individual of type X equals 0 in a close race, subtracting off the outcome for the individual of type 0, which beats an individual of type X in a close race, so they narrowly win. So the two key things which are changing about these designs is that we're focusing only on comparing winners, and secondly, we're focusing on so conditioning on a predetermined variable X and Xi and Xj that could in principle affect the differential in vote shares. And so this part is sort of the really important thing for thinking about where the bias might come in. A simple example which sort of illustrates where the bias can occur. So we're going to say there's only a single compensating differential Z. So this is like the thing which allows people with and without X to be in close selections with each other. We'll say that's normally distributed. And importantly, it's going to be independent of X. So that means that at baseline, like X is not correlated with Z until, as I'll show you in a second, we start conditioning upon close elections. In addition, there's going to be some noise. So we're going to say that these epsilon E's are going to be normally distributed. Again, they're going to be independent both of Z and X. And so we can think of these E's as being sort of like random shocks that meant that an election was close, which are uncorrelated with any candidate characteristics. So it could be like, you know, the weather was particularly bad in like a part of a constituency that you know, was very densely populated with X voters or not X voters. For simplicity here, I'm going to say that the candidate vote share is a linear function of the difference in the X's and the difference in the Z's between sort of candidate I and candidate J. This isn't sort of necessary for the results, but it helps for a simple closed form solution for the example. I'm going to say that the coefficient alpha is positive, so we're going to be saying that X is always desirable. So having the characteristic X helps the candidate have more votes. The compensating differential obviously is going to have to also be positive in that case, but you can always rewrite, you know, Z as being minus Z, and like this is going to hold. So these are not sort of restrictions in a meaningful sense. It's just my way of ordering whether a candidate's characteristic is better or not. Potential outcomes, as I've already mentioned, are not going to be a case where a candidate doesn't win because like they didn't have the opportunity to serve in office and pick you know, whatever policies they might pursue. So we're going to say the potential outcome in the case where the candidate does win is going to be a treatment effect of tau associated with characteristic X. So having X is going to increase the outcome by tau. Having the characteristic having characteristic Z is going to increase the outcome by gamma, and there's going to be some random noise that means that sometimes districts perform better or worse in terms of Y. So the kind of key thing to note here is what the close election condition implies. So saying that the candidate of type X equals 1 has the same vote share as a candidate of type X equals 0 implies the following condition. So this is, and so what you can see is that for this V1D minus V0 is equal to 0, it is going to be cancelled out either by the beta times the difference in the Z's or the difference in the noise terms. So to put that in slightly different terms, like an election is only going to be close if a compensating differential exists, that the candidate without type X has a higher value of Z, or there's some kind of random noise that systematically means that like candidates of type X are going to sort of be disadvantaged. You know, we can think of this as like picking like a particular point in the normal distribution that exactly compensates for alpha. So I won't go into the details. I mean, I'm happy to share the paper later, but we can basically sort of derive the exact bias in this sort of PCRD estimator under the continuity assumption, and then applying like these distributional assumptions in the simplifying example, like the normal distribution, like the independence between the XZ and the noise. See come out of this is that the bias relative to tau, so tau is the thing which we should be estimating, like that was sort of by construction in the potential outcomes here. Like we're going to see this term sort of on the right, which is going to capture this bias, and this is going to be increasing in alpha, like the effect of X on vote share. Going to be increasing, not super surprisingly, in gamma, the effect of the Z for the compensating differential on the outcome. So the more that the compensating differential matters, the more bias you're going to see in the effect of X, as well as the sort of signal to noise ratio. So this is the sigma sort of squared, like the variance of the Z and the variance of the epsilon distributions. Like the more you have of sort of variance coming from Z, like the less likely it is that you could be generating close elections because of the random noise. So that's sort of hopefully all fairly obvious and straightforward. Whether this is sort of like an upward or a downward bias in magnitude is going to depend on whether the sign of tau agrees with the sign of gamma. So this is sort of hopefully is starting to link back to the previous examples where we see this upward bias in the case of gender, because like gender was like a situation where the compensating differential effect captured by gamma was positive, but the effect of tau was positive, but like the alpha was negative because like there was this bias against women, despite the fact that women produced more of the outcome, whereas the reverse occurred in the Democrat versus Republican example I gave. So I think it's worth pointing out there's sort of several cases of conditions where we're not going to have biased estimates here. The first one is no compensating differential is required. So alpha is 0 because like there's no effect of gender on vote share, or there's no effect of being a Republican or a Democrat on vote share. And so there's no need for a compensating differential. Like you don't need to have more of the characteristic Z to compensate for the fact that you don't have the characteristic X, because nobody cares about X. So this is sort of like one special case where this design is going to be unbiased. The second special case is going to be where the compensating differential doesn't affect outcome. So even though you need Z in order to compensate for the fact that you don't have X, the fact that Z doesn't ultimately affect the outcome means that there's not going to be any bias. And this is pretty closely related to the noise term. So like remember that the epsilons are these things that don't affect the potential outcomes, but they do affect the vote share. So we can think of like those two conditions similar. And so this is like the third condition where like we only have close elections because like the noise exactly cancels out the advantage of having X. So I think in general, like this only types of elections which we see it even in expectation are going to be ones where like there just happen to be random shocks that compensated for these effects. Like there's sort of like it seems pretty implausible once you enter into sort of more extreme parts of the distribution of epsilon that there's going to be sort of like basic, like you essentially need a uniform distribution in those areas where we're in close elections, where we have positive alpha and we have noise that compensates. And if that's not the case, then you're going to have some kind of systematic bias. So I'm mostly going to focus on these first two conditions because one, they're like more substantively relevant, and two, they seem a little more plausible.
Can I jump in and ask a question about what you're viewing as noise? Because I was taking that to be that there could be district characteristics you might not observe, like shifts in demographics, or as the example you gave of national mood. And most of those things would probably affect outcomes as well. Like there's unemployment goes up or down. And the first two, I mean, like, so it seems like if you're willing to say that this is just due to noise and not some underlying thing that might affect the outcome, you're giving these designs a sort of free pass on actually, I think, the hardest problem.
Yeah, no, I totally agree with you. I mean, like in terms of notation, anything like you're describing would have to go in the category of Z rather than epsilon. Like epsilon simply defined by it affects vote share but doesn't affect the district outcome, and the Zs would be anything like you described that affect both vote share and district outcomes, and the upsilon is anything which affects just the district outcome but not the vote share. But yeah, no, I totally agree with that view, and I think like why these designs are so difficult to deal with is that there's a lot of potentially unmeasurable things that affect both vote share and district outcomes, and you have to make fairly strong assumptions about them, like namely, like the first two on this slide here.
So John, it seems to me that one kind of evidence that a scholar could bring in support of this design would be evidence based on data gathered from voters. That is, do voters perceive female candidates differently than male candidates? Do they perceive criminal candidates differently than non-criminal candidates? You could try to assemble evidence of that sort. Admittedly, it might be hard to do, but it wouldn't be impossible. Has anyone done that?
Sorry, my system just collapsed there. Can you hear me? Great. Yeah, so in principle, you could do exactly that type of thing, and I think it's not really been done very much, like what people's perceptions of these candidates look like. But I think that would be a good way of like helping to substantiate this, and so I'm going to sort of mention that a little bit more going forward as well. So let me just talk quickly about the general result. I mean, like the general result is pretty much the same as the sort of specific example result I just showed, but in a much more general setup. So here, what I'm going to essentially show is that we can leave the kind of vote share function essentially unrestricted as being like a random function that takes on sort of systematic sort of variables like the x's and the z's, as well as random shocks, and there's sort of like no structure imposed on that v function, and the only structure imposed on the additive separability between the effects of the x and the sort of other factors. This additive separability I don't think is necessary for the result, but it's like the only way in which I found of like providing a fairly sharp sort of derivation for the bias. So that's a limit of where we're currently at, not a super important one. So the kind of the key results, which sort of generalizes what I just showed, is going to be sort of like all the differences between the outcomes for heads due to the fact that they differ.
I'm sorry to I'm sorry to interrupt you, John.
This sort of somewhat three ways
John,
in which bias won't arise, where the compensating differentials, the random noise is sufficient to cancel out the impacts of
John.
Of x, and because the random noise doesn't affect the outcome, is generally not one which. So I mostly want to conclude by sort of offering with this, which
John, I'm sorry. I'm sorry to
views on how effective they are. But I think like the first approach is simply to say, like, I'm going to invoke one of these additional conditions and sort of make a claim.
Stop. Matt is trying to tell you that your audio is a mess.
Yeah, thanks, Miriam. When you, yeah.
But we can't, you need to go back a slide. We can't hear you. Your audio's all broken.
When we were on the general results slide, we didn't really catch any of that. There was a lot of choppiness and in and out sound quality. Not anymore.
I think we hear some of the traffic behind you.
Okay, so it seems like you can hear me, which I guess is good. I'm going to try and move away from the traffic, which is bad. So many apologies for that.
We can hear you. We can hear you much better now. The traffic wasn't so much the problem as I think you had a bad connection for a moment there. Are you still there?
In terms of like what this can get you. So,
again, your connection seems to be very choppy. We're not very easily able to hear you. And
can you guys hear me?
That was clear.
That part was clear. It's been really spotty and kind of in and out for the last few minutes.
Can you guys hear me now?
Yes.
Yeah.
Okay. I'm really sorry for the background noise. As I warned at the beginning, the problem of being California, I'm afraid, with not great internet. But yeah, so let me try and wrap up these sort of points fairly quickly from here.
You may want to go back a slide or two. I think we didn't really catch anything.
So yeah, so we have these these three conditions. I think neither of the first two are particularly appealing for theoretical and empirical reasons. Like for the second condition, that no compensating differential affects any outcome. This is hard to ever compellingly prove because we can't really measure all of the possible compensating differentials, and we can't show compellingly without many different sort of identification strategies that none of them actually affects the outcome. So that's always going to be hard to prove. For the first condition that no compensating differential is required, this is a bit more straightforward in the sense that we only need to focus on showing one thing, that X doesn't affect V. But obviously, we also need a design to show that X doesn't, in fact, affect V. So this is going to be somewhat demanding, but perhaps not as demanding as condition 2. For the reasons I've given, condition 3 is, I think, not terribly plausible, and again requires that we can measure all the possible Zs, but now without the kind of the normal RD presumption that balance is going to hold, and we simply need to show for some covariates that it seems plausible rather than for all of them. I think kind of the more interesting point in some ways is theoretical here, in the sense that what we kind of need in the case where effect that's not zero would need to be oblivious to the impact of X on the outcome for them to still like be willing to have sort of like a candidate who like affects the outcome, but then they not to sort of focus on that basis. This sort of world in which X matters, but voters don't perceive X to matter. So I think these are sort of the reasons why this design is not necessarily particularly plausible on its own. Like there's a variety of different strategies that I'll talk very briefly about, because I know we're coming up to time here. I'd say that sort of continuity and balance tests take on a different meaning in this context because we can't assume that the design works in the way in which it normally would. It's no longer the case that like showing balance across lots of different variables is going to convince us that this design works, because there's a presumption by sort of construction that there should be some variables which are imbalanced when these conditions don't hold. And so in some ways, like we might think of balance tests now as being manipulation checks, where we in fact look to see an imbalance in order to confirm that the design works, because we should expect an imbalance if conditions 1 or 2 don't hold. Similarly, covariance adjustment doesn't really work, I think, in this context, because even if you're able to condition on some like potential compensating differential, that doesn't obviate the need to have some other compensating differential. Like even if like you condition on competence, the fact that a woman is still in a close race with a man requires some other compensating differential to overcome the facts that like the woman has a bias against them in the electorate. And so whilst that differential might not be competence because you're conditioning on competence, it has to be something else instead. And so there's always going to be sort of a need for a compensating differential that covariate adjustment's not going to be able to solve. It might do a better job at dealing with condition 2, but again, probably not going to be sort of perfectly conclusive. As I previously mentioned, like bounding is to some degree an option here. We might say that if we think there are good theoretical reasons to think that the estimate is an underestimate of the treatment effects, like the Democrat-Republican example, then we can say directionally that we think X has a positive effect of at least the magnitude of our RD estimates. But again, you know, like this is going to require a fair amount of information about the effects of lots of different compensating differentials and the effects of the sort of X on the sort of like the vote share as well. So this again, I mean, I think this is like a more appealing way to go, but it does sort of prove tricky in some ways. It's also important to emphasize that it's not very good for certain types of hypotheses. So in particular, like if you're trying to prove that there's a null effect of something, like this design is not going to be very helpful because you don't know whether the null effect is because of the compensating differential or because of like the effect of X is actually 0. Another kind of strategy kind of along these lines is sort of like theoretical implications, so empirical implications of theoretical models, and that would be sort of like generating differential predictions of different types of compensating differential and showing like, you know, these ones which are consistent with the mechanism X, you know, like we're seeing moderation effects, or we're seeing sort of like intermediate treatments, so showing effects consistent with the effects of X, but not with the effects of compensating differentials. I think this is like a common empirical strategy for, you know, like understanding mechanisms and can apply in this context as well. As I previously mentioned, the kind of the ultimate trade-off here, I think, is between a design which induces bias by construction versus a sort of like a design that can condition on like a particular vote share and potentially reduce biases in that way. And you know, I think that's the right way to think about it. And I think it's quite plausible in many cases these designs are better than nothing. But I think one kind of interesting approach, and sort of my final point, is whether or not it makes sense to sort of broaden the definition of treatment to include all of these compensating differentials. So we might say, you know, I'm not interested in the effect of gender. I'm interested in like the effect of gender and everything which comes with it. And so the way in which this deals with this problem, as I think Dan would agree, is that you're just going to say that like an extremist candidate or whoever is a bundle of all of the things that come together with that candidate, and so like there's no such thing as a compensating differential. And so in some ways, like this means that balance tests are actually quite useful now for better defining what the treatment is. So the treatment is not just the extremist candidate, but all of the other imbalances that come with it. And so, like, you know, in some ways, seeing imbalances is helpful here because it helps us to understand what the meaning of treatment is. I think the limitations to this are, you know, first off, like, you know, we often, for policy or academic reasons, want to be able to attribute the effect to X as opposed to X and the many things which come with X. But you know, that's obviously in the eyes of the beholder. I think that the trickier aspects of this are that this bundle is kind of atypical by construction. So like it's not the typical extremist or the typical woman precisely because of the need for compensating differentials. It's like, you know, the atypical woman who happens to be like better than other women, or at least like the typical woman who's competing against an atypically bad man, or like the extremist candidate who is like atypically competent to compensate for the fact they're so extreme that people are put off by them. And so I think this is sort of like an external validity implication, but at least this collective approach does sort of help to address the internal validity side of things here. So that's basically all I have to say. Like I apologize like the background traffic, as I mentioned at the outset, like there's a bit of a conflict between us being on our 5-year anniversary trip and being in California with more limited access than normal. So I really do apologize for the interim. Thank you for the heart, Miriam. So just to conclude, I mean, like what I hopefully showed you here is that PCRD designs can generate compound treatments to a form of post-treatment bias, and that this bias is quite hard to undo unless you're willing to make assumptions which I think are much, much stronger than what typical RDs normally invoke, and which sort of based on sort of theories of political science, like are fairly implausible in most contexts. Like these claims that like the characteristic doesn't affect the vote share but does affect the outcome seems sort of counterintuitive in many contexts, and like the claim that compensated differentials don't matter is simply hard to verify. So thank you everyone for enduring that like tricky last section, and I really appreciate the opportunity to present this to you.
Well, thank you very much, Sean. I'm aware we are a little bit past time, but if anyone has any questions to close us out, feel free to hop in. Also, obviously, as we are past time, feel free to drop off if you have other things to be doing. But just want to once again thank John, and I guess we'll stay on the line for a moment for questions, and then wrap things up. Jake, was there anything else you wanted to add?
Nope, just love to hang out and hear some discussion if we have some. Especially here, I'd like to hear from Dan in particular.
Yeah, I mean, it's really interesting stuff. I mean, I think you characterized a lot of this, I think, correctly in some cases. The thing that I was curious about is I mean, I had two big questions, two broad things. One was a question about just about characterizing this literature, to what degree it is the case that this is the estimand that people are proposing in the papers. Like my impression is that the interpretation that you mentioned for Andy, a paper of Andy and mine, another paper of mine, another paper of Andy's, is much more common than you described. I may be wrong. Like I may need to go back and read some of these abstracts. But I think it is I mean, it's clearly the case that like if we define the estimand in the way that you've defined it, that all of these issues arise. But I think the one challenge I have, or the one thing that I'm not clear on, I'd love to hear your thoughts on to understand a little bit better, is this is why your view is that this estimand, once we move to the bundled treatment, is not policy relevant? Because it does seem like most of the cases that we're interested in are the cases where it's plausible that an extremist could be nominated versus a moderate, or where a Democrat could be nominated, it could be elected rather than a Republican. Those are the exact cases where we could imagine changing, manipulating. So like if what we're interested in is like, if you're an activist and you're considering like putting in a little bit of resources to narrowly elect a Democratic member of the House, like the cases that we care most about are the ones where a Democrat is narrowly lost, and we could, with a little bit more resources, increase the vote share for the Democrat and elect that Democrat to Congress. And then we want to look at like how much they support our issues or whatever. And so in those cases, it seems like that's like, at least in a lot of the cases when I'm thinking about the policy relevance, it seems like exactly the part of the kind of the area of the vote share distribution that I'm interested in is close to that 50-50 case. And so I was curious to hear a little bit more about that. And then the other thing I just wanted to flag is that I think in the exact example that you have, there's a really neat Buena Mesquita, Ashworth, and Chris Berry paper looking at exactly this question of like applying a formal model to extract some of the same findings that you have here on gender and this gender-based RD that you're describing. And so I think it would be useful just to have a look at that as well. Anyway, this is great. It's really interesting work.
Should I take a moment to respond? Yeah, I mean, that last point, I haven't seen this paper, but I've heard about it from some other people. If you're able to share it with me, that would be fantastic. I've not been able to find it, but yeah, that would be super helpful. Yeah, I mean, in terms of your first point about characterizing the papers, it's obviously kind of difficult. I mean, I think like you and Andy are like a way out in the extreme, in my opinion, in terms of like how careful you are in interpreting what the treatment means in these papers. And I think you have like the sort of the most compelling strategy for like saying something interesting about this and like being careful about what it actually means. My take is that most of the papers don't do that, and like many of the ones in gender context do, but like most other areas they don't, and virtually none of the sort of Republican versus Democrat type papers do this at all. My take on this is that even in the cases where people do talk about some of these things, it's typically in the context of the bundle treatment that like Democrats are like more likely to be women, they're more likely to be black, they're more likely to be all these things in a sort of like unconditional correlational sense, not recognizing that they sort of also have these compensating differentials. But nevertheless, I mean, I think most of the papers ultimately are typically trying to make the claim that like they've said something about the effect of X, like they might hide it behind like some other sort of like caveats about it, but like the broad claim is pretty much like there's an effect of X. I found in most of these papers on reading them. But yeah, I certainly need to be careful not to mischaracterize how people are doing this, and it's obviously tricky to code a lot of these papers. To your second point, which I think is the most important one about like whether like the fully bundled treatment is relevant. Yeah, I mean, I'm totally with you from the sort of perspective of like where the only thing which you care about is like is electing a Democrat over a Republican important. I think your point is totally right. I just think that there's like several other things which we often care about, like the academic kind of, what is the mechanism? Like, is it because they're a Democrat, or is it because like they're unusually competent or whatever? I think is academically interesting. And I think from like the policy perspective of like what type of policy, if we could pick amongst a plethora of options, would we use to sort of like remedy whatever the problem is, I think it's also tricky for that. So I think in the case where like the only tool you have available is like more Democrats or more Republicans, then I think your point makes total sense. But if you could design an institutional reform that was like to get at like all the different possible attributes and pick the ones which are most effective, then like those types of designs are, well, that interpretation of the design is not going to be quite so helpful. So you know, I should be super clear, and like I'm sort of working through this in the paper, that I think like this is by far the best thing, and like it gives you an interpretation which is meaningful. It may just not be the thing which what I take a lot of the people other than you guys to be getting at is what you're saying.
John, if I could follow up, you mentioned that, talking about bundled effects, but under your framework, any district or time period effects are bundled into Z. So in what sense, like, are there bundled effects, right? This isn't just, women tend to be more liberal, or, African-Americans tend to be Democrats.
Yeah, so and this is kind of the like substantive question about like what goes into X and what goes into Z. And I think Dan's answer is that everything goes into X, and the X is just capturing all of the possible bundles. I think a lot of the literature's answer is like, there's some things which are in X, but there's some things which are in Z, which we don't want to be claiming this is the effect of. And you know, I don't have a strong position on this. I mean, I think, as I just said, like the putting everything in X is somewhat appealing in some ways, precisely because you don't have to deal with like the fact that there might be these Z's which are causing confounding. But it does come with this trade-off of like X sort of starts to become much less meaningful if it's like everything which is both correlated with X in a sort of unconditional correlational sense, plus all of the compensating differentials that are induced by using this type of design. Is that what you were getting at?
Sure, I'm not sure there was an answer to that, so just curious.
John, I have a clarifying question about the running variable. So in these examples, let's say we're focusing on gender. The running variable is the vote share for a female candidate minus the vote share for the strongest man candidate in the district?
Yes, that's right.
Okay, and so if that's the case, wouldn't we expect that the compensating differential variables would be the same across the threshold? Then if a woman beats a man on the right side of the threshold by whatever, and there's like some competence, so some difference in competence, shouldn't we expect the same differential in competence on the left side of the threshold while the woman is losing to a man?
Yes, I mean, this is obviously like the sort of the core of what. So if we're simply like looking at winners versus losers, then that would be right. Like, it's precisely because in these designs that we're only ever comparing winners to winners. So like it's always comparing a man that just won to a woman that just won, but they're not they're not in the same race. And like that's the sort of the key thing. So the fact they're not in the same race, but they're still in a close election and they differ in some other way, like that's where the sort of the source of the discontinuity in other characteristics has to come in. If we think that like being a woman leads to like a higher or lower vote share. Does that help answer the question?
More or less. I'm a little bit confused because if we're thinking about districts, then we're comparing a district where a woman narrowly won over a man to a district where a woman narrowly lost to a man, or where a man narrowly won to a woman. And so in theory, those districts should be very similar. And it may be the case that the difference in, let's say, competence between that man and that woman in both of those districts is exactly the same, and that's why the margin of victory. Oh, I see. It's because then the competence is being imputed into the randomness of the close election. That's the claim.
Yes, I mean the issue would be that like the woman is only in a close race with the man because they're more competent. And so I think that may be what you were just describing. Like the other kind of interesting thing about what you just said regards whether districts are similar. So like you might think that maybe this is a problem which applies to individual level characteristics like competence or gender or whatever, but doesn't apply to district level characteristics. And my initial insight was that these district level characteristics should still be balanced precisely because they're these close elections, but that's actually not quite the case. So the reason that's not the case is that it could be the case that some candidates or some types of candidates benefit from particular types of like district characteristics. So if we think that like districts where there are more women are likely to reduce the bias associated with like women candidates in terms of their vote share. So we would then think that like this is going to be inducing a correlation between like women candidates and the type of district. Whilst I think it's generally more plausible that like district level characteristics are less likely to be imbalanced, like they're not necessarily going to be imbalanced just because of the possibility there's an interaction between a common district effect and an individual level characteristic in terms of its impact on the vote share.
Okay, yeah, this is helpful. But as long as, say, we could claim that the vote share is not directly affecting the outcome by showing like the balance tests and the other tests that are common, then at least at the district level, then of course we are imposing stronger conditions because we're also claiming that the differential in the characteristics of the candidates are not affecting the outcome directly. But then as long as we could show that at the district level, because we're comparing outcomes at the district level and the unit of analysis is the district, then we should be fine in terms of showing that the assumption should hold. That is that the margin of victory does not affect directly the outcome. And we know that that's the case because the characteristics across the districts are balanced. Would that satisfy some of like the strongest assumptions that we're imposing with these types of designs?
I think it's going to help. I mean, I wouldn't go as far as saying this solves the problem. I mean, like the thing which you would want to be able to show here is that like gender doesn't affect the vote share. So I think if you were trying to identify the effects of gender, then like best case scenario, like you would be randomizing whether like a candidate is female or male. Obviously, that's not terribly plausible, and so like maybe something correlational showing that in like close elections, like it's typically the case that there's like a limited correlation between candidates' gender and their vote share. I think that would help. I think it would also help to say, like, here's like 3 plausible compensating differentials. None of them seem to be correlated with the outcome of interest. And if you can do that with a more compelling design, then that would be better still. Like, I think those are the types of tests which you would want to run. And that obviously links to what Miriam was suggesting earlier as well, that if you could say run surveys and ask people, you know, like, would you be more likely to elect a woman than a man? And like you find like no real difference there, then that would obviously sort of help to support what I'm calling sort of condition 1 in this design as well.
It also strikes me that this is a nice design for sensitivity analysis because we have a name for some of the biases that we're trying to look for here. You know, we could say, let's entertain the idea that for some unmodeled reason, women are more likely to win. How much would that change my results? You know, rather than sort of the other stint in kind of ordinary observational studies where we don't know how to name the unobserved biases, and we just say, you know, if gamma is large or small or something like that. So I can see this design being like better than other designs because of the fact that you can focus on some of the biases. One question I was having, and maybe you can respond to that too, but you know, is there any benefit? Do these assumptions about bias have implications for comparisons that would be really bad? Like, let's take a woman who won narrowly. Should this person, are there patterns of relationships between her and women who win by landslides or women who lose by landslides? Like, you know, like, is there something that would that tell us anything about biases if we did sort of the opposite, rather than saying we're going to kind of really control for margin, we're going to in fact find the worst comparisons. Are those worst, are there patterns there that could inform us about bias? I really don't know the answer to that, but we have more comparisons in these data sets than these. And that's why I'm wondering if we could use them to make an argument.
Yeah, I mean, let me speak to your first point first, which I think is a really good insight. And I kind of skimmed over this pretty quickly towards the end. So like one of the advantages of balance tests in this context is that if you find an imbalance for a particular variable, that tells you this is something which could be a compensating differential. So like I should look to see like, you know, how bad the bias associated with that potential compensating differential need to be in order to sort of like, you know, nullify my results. And so I think you can do something similar to what Conley et al. Do for exclusion restrictions in the context of instrumental variables, where you sort of like keep varying like the gamma, like the effect of the compensating differential. And you can say like, how big does gamma need to be conditional upon what my balance test shows to be the level of imbalance between the Zs to sort of like, you know, produce a result which is 0 or produce a result which is like, you know, some value which is sufficiently low. So I think that's a really neat thing about the design. And like, as you say, like one thing which is good about these designs is they provide a lot more structure than like a sort of like a bivariate correlation or a multivariate regression analysis would. And you can potentially do even better than what I just described. Like if you have like a causal estimate from another context for gamma. So if you know exactly what gamma is, then you can do something more precise than just a sensitivity analysis and say like, this is like the bias adjusted sort of estimate. Obviously, this still requires you have estimates for every possible compensating differential, and some of them might be unmeasured because you can't observe the Zs. But I think that's like a pretty promising way to go. To your second point, honestly, I haven't given that so much thought. My instinct is that like these really radical comparisons kind of go against everything which I would think you would want to do for causal inference. But I'll try and give it some more thoughts as to like whether like that might be able to tell us something about like the nature of the types of biases you might need to look for, or like whether or not like there are compensating differentials in the first place. I mean, like,
yeah, that was my thought. It's like, yeah, the point isn't to use it for the causal inference, but to sort of help you nail down certain kinds of biases by making bad comparisons that from a causal inference perspective. But I'm sorry, it's kind of a crazy. I saw something like this. Paul Rosenbaum did something like this where he made some, but I'm losing the thread of his argument. So I'll try to dig that paper up in this case too.
Yeah, no, please do. And like the craziest things are often like turn out to be the best ideas. So I mean, obviously they often don't as well. But
right. All right. Anything else, y'all?
Yeah, this is all really interesting. Thanks for presenting. I think I still want to understand a little bit more. I know I don't want to take us longer, but I still am a little bit turned around about how many of these papers are literally proposing the estimand of replacing the party label like Democrat and Republican. Like I understand that it's plausible that some of them are doing that. But that's the one thing that I'm still hung up on. Maybe I can email you offline and we can I can learn a little bit more about it.
Yeah, no, please do. I mean, this is the part which I'm most nervous about. Like all the proofs I feel confident to write, like the interpretation of like what authors give to these estimands is like the part which is more sort of open to interpretation. Like I'd be very happy to chat with you like sort of off this Zoom at some point. I'm actually meeting up with Andy on Friday, so I can get his opinions on this too. So
cool.
I appreciate that.
Yeah, thank you.
All right, sounds like we've hit the end of the questions as well. Thanks everyone for sticking around, and especially to John for sticking around and for kind of serving as the guinea pig for the first of these summer methods talks. I think this is a really exciting paper, and sounds like you got some good questions and comments and feedback. So hope everyone else found this to be a useful exercise, and it encourage you all to look for emails regarding future presentations. And with that, I'll call it a day. Thanks very much, everyone.
Yeah, thank you, everyone. Really appreciate it.
Thanks all. Thanks for coming. Thanks a lot, John. Thanks, y'all.